All right, guys, welcome to Semester 2, Week 2 FRQ notes found on page 190 of your FRQ books. We're going to be doing Part B of Question 6 on the 2008 FRQ. So let's begin. Let f be this function. And notice that x has to always be greater than 0. And then they also tell us the derivative of f is equal to this. They're asking us to find the x-coordinate of the critical point of f. They also want us to determine whether it's a relative min, max, or neither, and justify our answer. So we're given three things to do. Find an x-coordinate of the critical point, determine whether it's a relative min, max, or neither, and then justify our answer. Okay? So we've got our work cut out for us there. Begin. All right, so as you guys may recall, a critical value is a place where either your derivative equals 0 or where your derivative is undefined. Okay, so where would this derivative be 0 or undefined? Well, let's go ahead and set it equal to 0 first and see where it equals 0. So to solve this equation, multiply both sides by x squared first. 0 times x squared is still 0. Let's go ahead and add ln of x to the other side. So now I've got ln of x equals 1. Now this is where some pre-calculus knowledge can come in handy. An ln is a base of e, and you could rewrite a log as an exponential function where you say e to this power equals x. And so the answer is e. Okay. So we have one critical value. It's e. Let's see if we can find another critical value. I'll put that answer here because that's where I said it equals 0. What about where f is undefined? Well, this function would be undefined anytime the bottom equals 0. But the problem is x has to be greater than 0 anyway, so we can't really even consider that one. So we end up having only one critical value. All right, well, there you have it. We've kind of answered the first part of the question, what is the critical value? So that's all done. Now we need to determine, is this point a relative min, max, or neither? And the way you're going to know that is by doing the first derivative test. So let's begin our first derivative test. So with the first derivative test, the first thing you do is find your derivative, but we already have that. Then you find your critical value. We already did that. We found out it was e. The next thing we do is we do the number line part of this test, which is where we put our critical value here. Now our function has to be greater than 0, so I'm going to put 0 on this side, but there's no upper limit, so it can go up into infinity on this side. Now, it's going to be helpful for you guys to, once again, have some more pre-calculus knowledge here. E is about 2.71. Okay, so if that's 2.71, then the number that maybe would be a good pick right before that would probably be like a number 1 would be a good choice. Okay, so we know we're going to pick that, and we're going to plug it in here. So we're going to find out what's f prime of 1. And then after that, we're going to find out f prime of something else. Now, you might think, let's do f prime of 3, and that's fine. The problem is that this is question 6, and on calculus questions, the AP exam, FRQs 4, 5, and 6 are never calculator questions. And so that kind of leads you into some issues there. You could do 3 and just kind of ponder, but I'm going to get tricky here. I know that ln and e work really well together. Since this is e, what's another number that has e in it that's bigger? And I'm just going to go ahead and say e squared. And you guys might think, oh my gosh, Mr. B, that's crazy. How would I have known that? Well, I'm showing you. That's how you'll know it. All right, so let's go ahead and do this. Let's find out what f prime of 1 is. So if I were to plug 1 into my derivative here, I'm going to end up with 1 minus ln of 1 over 1 squared. Now, more pre-calculus knowledge, ln of 1 is 0. So we have 1 minus 0 on the top, which is 1. 1 squared on the bottom is 1, and so we end up with 1. That's a positive number. So my function is increasing on this interval, since my slope is positive. All right, let's do the next one. I'm going to plug in e squared this time. So that's going to be 1 minus ln of e squared over e squared squared. All right, well, ln of e squared, another good pre-calculus rule is the fact that anytime you have ln of e to a power, basically the ln and the e just cancel each other out in a sense, and you're left with just the power itself, which is just 2. E squared squared is e to the 4th. Now we know that this is just a weird number, it's 2.71. So if you raise it to the 4th power, guess what? You've got a positive number on the bottom. On the top, I've got 1 minus 2, which is negative 1. So if you have a negative number on top and a positive number on the bottom, when you divide those, guess what you get? I don't know what the answer is, but I do know that you end up with a negative number there. So my slope is going down, which means that at this point, at this critical value, since we're going from increasing to decreasing, this must be a relative max. Now you have to remember how to write your answer to these, though. How you write your answers is very important. Let me show you that. Now, I would assume that showing all the math I just showed would be required as well, but the final answer should be worded like this. Since f prime changes from positive to negative at x equals e, f of e must be a relative max. Okay? So just notice the details here. I'm emphasizing it's going from f prime is going from positive to negative, and then I'm emphasizing the critical value there. And then notice here I say that the original function at e must be a relative max. Okay? And that answers the last two parts of the question, which is determine whether it's a relative min or max, which we did, and then justify your answer, which the justification is the math you showed plus that sentence I told you to write at the end. So let's see how they would distribute the points for this question. So on the left there, you can see how they've written their answer. You get 1 point for identifying your critical value. You get 1 point for identifying that it's a relative max at that point. And you also get another point for your explanation, that little sentence that we wrote. So that's a 3-point question. That's a pretty hefty pointed question there. Good one to know. Let's go ahead and move on to our other FRQ for this week. Okay, so welcome to the next part. We're going to do page 192, which is the FRQ for the year 2007, question number 6, part B again. Let f be a function defined by this. Once again, x is greater than 0. That'll happen anytime you have an ln, by the way, because that's their domain restriction. That's where they're continuous. Also, where k is a positive constant. In other words, we want to treat this letter k here like it's just a number. Okay, it's not a variable. It's an unknown number, whereas x is a variable. That's like an input which is going to change value over time. The k is just a fixed value, but we just don't happen to know what it is. So for part B, is asking us what value of the constant k, for what value of the constant k does f have a critical point at x equals 1? So basically they want us to find k when our function has a critical value at x equals 1. For this value of k, determine whether f has a relative min, max, or neither, and then justify your answer. Pretty similar second part to the last question we did, but the first part's kind of weird. It also is similar. We're talking about finding critical points, but this time they're telling us the critical point and asking us to find this mystery number. Another thing that's different is on the last problem we did, they gave us the derivative, but on this one, we're going to need to find the derivative ourselves. Okay, so let's begin. Let's go ahead and start with this first part of the question. For what value of the constant k does f have a critical point at x equals 1? Well, since we're looking for a critical point, we know we want to look for those places where f prime is 0 or undefined. So the first thing we're going to want to do is find our derivative. So, well, k in this case is just a constant multiple. And constant multiples usually just stay right where they are. They don't change. But we do have a derivative rule for square roots. The derivative rule for square roots is 1 over 2 times that square root. The derivative ln of x is 1 over x. All right, so there's that. So let's go ahead and solve this for finding our critical values. So for critical values, where is it undefined? Well, the first place it's going to be undefined is anything that makes the bottom numbers equal 0. So it doesn't matter whether you're looking at this denominator or this one. In either case, if x equals 0, then the bottom equals 0. So one of our critical values then is going to be x equals 0 because that's where the derivative is undefined. But where else can we have a critical value? We can have a critical value anytime the derivative equals 0. Oh, minus. Okay. Now, here's the thing about this, though. I just realized we don't really care too much about this. Do you know why? They tell us what x equals. They tell us we've got a critical point at x equals 1. So we don't care about this critical value. I'm not going to solve for x this time because I don't need to. They're telling me what x equals. So what I'm going to do is I'm going to plug 1 in to both of these denominators now. So that gives me 0 equals k times 1 over 2 times the square root of 1 minus 1 over 1. Okay, well, this is just 1. And 1 over 2 times the square root of 1 is just 1 over 2. There's that. And then I'm going to add 1 to the other side because I want to start solving for k, right? That's my goal. So now I've got 1 equals k times a half. How do I solve for k? Just multiply both sides by the reciprocal of this fraction. So I'm going to multiply both sides by 2. That cancels those out. And we end up with the fact that k equals 2. And voila, we've got the first part of this question answered. For what value of k do we have a critical value at 1? It's 2. How did we do it? Critical value told me I need to find the derivative. I found where it's undefined. That's where x equals 0, but we don't care about that because we want where x equals 1 as a critical value. So we do the 0 one, and we plug 1 in for x to solve for k. All right? Now notice I didn't really have the path clearly defined in my head of what I was going to do yet. I just knew that since it was a critical point, I needed to find the derivative and do the two things I always do. And as I was doing that, the process became known to me. So just start with what you know and feel your way through it until you get to a place where you need to be. Let's go ahead and move on to the next part. They want to know for this value of k, determine whether f has a relative min or relative max or neither at x equals 1. And just like on the last slide, we're just going to do the first derivative test for this part of our question. And for the first derivative test, you need to find your derivative, which we've already done. But this time, we already know something. We know that k equals 2. So at this point, I'm going to go back and I'm going to replace this k here with a 2. And actually, by doing that, I can see something's going to happen. By putting a 2 here, these are going to cancel. And I'm going to have a much more simplified looking derivative now that will be just 1 over the square root of x minus x, 1 over x. Okay? So there's that. We've got our critical values. I already found 1. One of my critical values was 0. And they're telling us our other critical value is 1. So we've got our critical values already. We just need to go ahead and do the number line test now. So here we go. 0. And I'm going to put that all the way at the end because, once again, we're only looking for all values of x greater than 0. And then we have 1. And after that, we can go on up into infinity. So I've really got 2 intervals that I need to look at. So I need to figure out what's f prime of a number between 0 and 1, and what's f prime of a number between 1 and infinity. Now, once again, we're on question 6. And that means no calculator. Okay? Now, you might be able to be fine plugging in any point you want to. And you probably would get the answer anyway, but I want to pick a good number. And what do you think think makes this a little bit challenging here. I think the square root's going to cause a problem for us. You know, if you don't pick a good number, taking a square root becomes complicated. So my encouragement to you is to pick a number that has a nice square root. So what's a number between 1 and infinity that has a nice square root? Well, how about 4? I'm going to go with 4. All right. What's a number that has a good square root between 0 and 1? Now, it might be a little bit harder for you, but guess what? It's 1/4. That's between 0 and 1, and 1/4 has a nice square root. I think that'll make things a little bit easier. So let's go ahead and plug these in and see what happens. So 1 over, let's do the 1/4 first. Square root of 1/4 minus 1 over 1/4. All right. Well, we talked a while back about how to simplify complex fractions. I don't like this 1/4 here, so I'm going to multiply it by its denominator. Because when you do that, those cancel out, and I'm just left with 1. But what do you do to the bottom? You have to do the top also. So I end up with 4 over 1, which is just 4. Now this side over here, we have 1 over the square root of 1/4. The square root of 1/4 is 1/2. And when you repeat this process here, oh, it's not equals, my bad. Let me back up a little bit. It's minus. Square root of 1/4 is 1/2. We're going to multiply the top and the bottom by 2. The 2's cancel here, and I'm left with 2. So I have 2 minus 4, which is -2. Since my slope there is negative, then on this interval we're going down. All right. So let's go ahead and do the next interval. This time we're going to be plugging in, oops, wrong color. We're going to be plugging in just a 4 this time, not a 1/4. So I want to find out what's f prime of 4. So let's do that. 1 over the square root of 4 minus 1 over 4. The square root of 4 is 2. What's a half minus a fourth? Well, let's get a common denominator. I'm going to multiply the top and the bottom here by 2, and that'll give me 2/4 minus 1/4, which is 1/4. I don't really care about the number so much as the sign. I end up with 1/4, and it's a positive, so that means we've got a positive slope, which means that we have a relative minimum at the critical value 1. Okay, so we know the answer is it's a relative minimum, but once again, we need to know how to word that appropriately. So how should we word that? So as you can see here, same kind of wording as last time. Since f prime changes from negative to positive at x equals 1, f of 1 is a relative minimum. Once again, f prime is changing from negative to positive, critical value, x equals 1. Therefore, f of 1 is a relative minimum. So those are your key elements you want to have in your sentence there to make it complete. Let's go ahead and see how they would grade us here. Wow, I'm impressed. This is a 4-point question here. So first of all, they would want to see that you have set the derivative equal to 0 and plugged in 1. That's 1 point. Then they give you 1 point for finishing that and solving for k. Then they give you 1 point for recognizing that it is in fact a relative minimum, and then 1 for the sentence. Now you'll notice their sentence is very different than mine. That's because they used a different test called the second derivative test, which we haven't learned about this week yet, but next week we will. But whether you use the first or second derivative test, it doesn't really matter. It's a relative minimum, and one justification is just as good as the other. So that's an impressive amount of points for a question. So, and just so you guys know, these types of questions are fairly, they happen once in a while, where they give you these questions where they ask for a missing number, a k value question of missing constant. Those are pretty common. So we'll go ahead and stop there, and hopefully that was helpful, and I'll let you guys work on your practice problems now. We'll see you in class.
All right, guys, so for this FRQ, which is in your blue books, it's FRQ 2005, and it's question number 4. Now, I'm going to do part A and B, but when I do part A, I'm going to do a little bit more than they're asking for, just because, on your quiz, I might be asking us to find a little bit more than that. So let's go ahead and get started. So they give us a table here. They're telling us that the function is twice differentiable except at x equals 2, so they put D and E here for does not exist. So they want us to use this table for part A from 0 to 4. That means we're going from beginning to end. They want us to find all the values of x for which f of x has a relative extrema. That means max or min. And then finally after that, we want to justify our answer. Okay. Now, there's two ways that you could identify relative extrema. One way is with the first derivative test. Another way is with the second derivative test. I think I'm going to go ahead and go with the first derivative test. So the first thing we're going to do is we're going to look for where f prime is undefined and where f prime is equal to 0. So we're going to look at our f prime row, and I see a couple of places here where f prime is 0 or undefined. Okay? Now, once we find those places, we look to the left and right of each one. So for 0, to the left it's positive. Actually, but before I go any further, we should probably put the x value. The x value at that point is 1. So for this one, if you want to put a little number line here, we have x equals 1, and we also have x equals 2. These are our two critical values, possibly. Okay? So x equals 1 and x equals 2 are critical values because that's where f prime is 0 or undefined. Now, if I look to the left of 0, it tells me that f prime is positive. F prime is positive. That means my graph is moving in an upward direction. If I look to the right of 0, it's still positive. So my graph is still going in an upward direction there. After the 2, however, it's negative. Okay? So, what does that mean? That means that this value is neither a relative min or max, but this number is a relative max. Okay? So, we would say there is a relative max at x equals 2. And I wonder if they want the y value. It says find the values of x. So we'll just put x. There is a relative max at x equals 2 since, and here's how you write your explanation. At that point, the slope goes from positive to negative. Actually, we'll say since f prime changes from positive to negative at that point. Okay. So, now, you don't have to show this work. You can, but you don't have to on your FRQ when you do this. What matters is this statement over here. You're going to be getting 1 point for identifying where your relative max is at, and you get 1 point for your explanation. So this is a 2-point question. All right. There are no relative minima on this, so we won't include that. Right. Now that's the that is the question that was being asked on part A, but Mr. Bailey's extra notes here, we get to call this. This will be helpful on your quiz. I'm going to find some other things, okay? So we found the relative extrema. We found the relative min and max. That's one thing that you'll need to be able to find. Another thing that you need to be able to find is critical values, and we actually already did that too. Critical values are those places where f prime is 0 or undefined. So that was these points here and here. And critical values are the x values that go with that. So the critical values are x equals 1 and x equals 2. This is one since at that point f prime equals 0. And this is a critical value since at that point f prime is undefined. And so those are your critical values. Now technically, just so you guys know, the point has to exist also. So for instance, even though f prime is undefined, the point exists. The point is 2, 2. Now if there was no y value here, that would mean the point doesn't exist, and that is not a critical value. But since both of these have y values, they're both candidates for critical values, and this one is a critical value because f prime is 0. This is a critical value because f prime is undefined. So we've learned how to find relative min and max. We've also reviewed how to find and explain critical values. Once again, you get 1 point for your answers, and then you get another point for your explanations. So that's kind of how this works. 1 point is the answer, 1 point is the explanation. All right, now another thing that you could be asked to find instead of critical values is you could be asked to find points of inflection. All right. A point of inflection is a place where your concavity changes from positive to negative or from negative to positive. In other words, the second derivative changes from negative to positive or positive to negative. But once again, the point has to exist. So here's a place where f double prime is 0, and if you look to the left and right, it changes signs at that point. So that's a point of inflection. At that point, x is equal to 1. Let's see if we can find another one. Here, at does not exist, we also change from positive to negative. So it's another switch there, and that is at x equals 2. And then, if you notice right here, we have another place where it goes from negative to positive, and that's at x equals 3. So there are 3 points of inflection. And right there, that would be worth 1 point, identifying all of the points of inflection. It's anytime you find a place where the concavity changes from negative to positive or positive to negative. Now for these, the answer could be the same for all of them because they all have the same explanation. And here's the reason. These are all points of inflection since f double prime changes signs at these points. So that's your explanation. You don't have to write a separate one for each one like I did over here. And the reason for that is because they all have the same explanation. Technically, this one changes from negative to positive. Technically, this one changed from positive to negative, and this one's negative to positive. But it doesn't matter what direction they change in for points of inflection, just so long as it changes. Over here, the critical values, I had to give separate explanations because they were for different reasons. This is a critical value because the derivative was 0. This is a critical value because the derivative was undefined. Okay. All right, let's go ahead and do one more thing that for Mr. Bailey's extra special notes here on the side. You guys need to do intervals of concavity. So concave up and concave down. Now that's going to be pretty simple because concave up happens anytime you have a positive second derivative. All right, so that would be, for instance, here. Oops. That's a positive, and that's a positive. So the intervals are from 1 to 2, and also from 3 to 4. Okay, so we would say it's concave up on 1 to 2 and 3 to 4 since f double prime is greater than 0. concave down is the opposite. You can see here that the second derivative is negative there. And it's also negative here, by the way. And it's negative here. All right? So for this first interval here, we would say 0 to 1. But for the 0, I'm going to put a bracket. 0 to 1. But the reason I'm going to put a bracket on the 0 is because the 0 is included. At that point, it's still concave down. Whereas here, this is an open parenthesis for the 1, and at 1, it's no longer negative. So I wouldn't include this one as being concave down at that point. Okay. Now, just so you guys know, I was told a while ago that AP doesn't care whether you use brackets or parentheses. So I won't care either, but I'm just being technical here. The other interval here is from 2 to 3. And the reason for that is since f double prime is less than 0. Okay, so once again, you wouldn't. I don't think I would ask both of these questions, but regardless of which one you answer, you get 1 point for the answer, and you get 1 point for your explanation. Okay, and that's it. So that's how all these work. 1 point for the answer, 1 point for explanation, and once again, you guys are going to be asked on your quiz to find a few different things. Critical values, relative extrema, points of inflection, and concavity. All of them you get 1 point for an answer and 1 point for an explanation. So regardless of which one you get 1 point for your answer and 1 point for your explanation. That's how they all work. Okay. Now, we're not quite done yet with this question. I'm going to go back now to finishing the FRQ. It says, on the axis provided, sketch the graph of this function. So, now I didn't provide a graph here, but in the original problem we did. All right, so I noticed that my x values are going from 0 to 4. So, 0, 1, 2, 3, 4. I'm noticing that my y values go from negative 1 up to a positive 2 is the max. So 1, 2. So first of all, let's go ahead and do our points that are defined. So we have the point 0, negative 1, which would be, oh, I missed that negative 1. There's one down here. 0, negative 1. We have 1, 0. We have 2, 2. And then we have 3, 0. Okay, so the points that we have. Now, notice that in between x equals 1 and 0, we have a negative slope. So between 0 and 1, we have a negative slope. I take that back. We do not have a negative slope. I was looking at the wrong one. This is for f. We have a positive slope between 0 and 1. When you're looking at slopes, we look at this row. So for the f prime row, that's our slopes. So between 0 and 1, we have a positive slope. So I'm just going to draw a line that connects those with a positive slope. Between 0 and 2, we have another positive slope. And then between 2 and 3, we have a negative slope, it says. And then between 3 and 4, we have a negative slope. All right. Now we're going to do our concavity. Now I'm noticing that from 0 up to 1, we have a negative concavity. So it should be concave down. So now I'm going to come over here. I'm going to take this, and it needs to be concave down with a positive slope. So that would look like this. Concave down, but still a positive slope. So I'm going to bend it like that. Next, between 1 and 2, we have a concave up. So I still want a positive slope, but now I need to bend the line so that it is concave up. So now we have that shape going on. Next, we have concave down from 2 to 3. So this little interval here needs to be concave down. Now notice the sharp turn here, and that makes sense because the first and second derivative don't exist at 2, so we have a cusp. Finally, between 3 and 4, we have a positive slope. I'm sorry, not a positive slope. We have a positive second derivative, which means that we're doing concave up. So here's our graph in its final form. So basically, you start off with your y values. After that, you sketch your slopes, but you're going to have to go back on your last step and bend those slopes so that they have the right concavity. All right? And that will be it for that.